When you gaze into the night sky, you see countless stars glowing gently against the darkness. They seem calm and unchanging, creating a sense of quiet beauty and reflection. Moments like this often make people think deeply about their place in the universe and how small we are compared to the vastness around us. For generations, humanity has asked one powerful question: are we alone, or does life exist somewhere far beyond our world? The idea of distant planets filled with unknown forms of life has always fascinated us. Throughout history, people imagined intelligent beings living among the stars. Different cultures created stories and beliefs to explain the mysteries above them. In ancient times, these ideas came from observation and imagination alone, with no way to test whether they were true. Today, science has changed everything. With modern technology, we can explore space in ways that were once impossible. Advanced instruments allow scientists to study distant stars and planets with incredible detail. Instead of relying on guesses, researchers now analyze real data gathered from space. One of the most important breakthroughs has been the discovery of exoplanets, worlds that exist outside our solar system. Scientists can now examine these planets closely, even analyzing the gases in their atmospheres. This is important because certain gases could point to the presence of life. These clues guide researchers as they search for living organisms beyond Earth. High above our planet, powerful telescopes continuously observe the universe. They have transformed our understanding of space and its history. These instruments capture light that has traveled for billions of years, allowing scientists to look back in time and learn how the universe formed and evolved. Among recent discoveries, one distant planet has captured special attention: K2-18B. Located about 120 light-years away, it orbits a smaller and cooler star known as a red dwarf. At first, it seemed like just another distant world. But further study revealed something far more intriguing. Scientists detected water vapor in its atmosphere, not frozen ice, but actual gaseous water. Since water is essential for life as we know it, this discovery raised excitement about the planet's potential habitability. Even more surprising was the detection of a molecule called dimethyl sulfide. On Earth, this gas is mainly produced by living organisms, especially tiny microbes in ocean environments. Because of this, it is considered a possible biosignature, a chemical hint that life might exist. Despite the excitement, scientists remain cautious. The data is still uncertain and requires further confirmation. However, even the possibility of such findings is enough to spark curiosity and open new directions in the search for life. K2-18b belongs to a category of planets known as sub-Neptunes. These worlds are larger than Earth but smaller than Neptune, and interestingly, they do not exist in our own solar system. Yet, they appear to be very common across the galaxy. Sub-Neptunes usually have thick atmospheres rich in hydrogen and helium, making them very different from Earth-like planets. These dense atmospheres can trap heat efficiently, creating unusual environments that scientists are still trying to understand. K2-18b orbits very close to its star, completing a full year in just 33 Earth days. However, since its star is cooler than our Sun, the planet's temperature may not be as extreme as expected. Some researchers suggest that K2-18b could be a type of world known as a Hycean planet, one with deep oceans beneath a thick, hydrogen-rich atmosphere. Such environments might support life in ways very different from Earth. Life, if it exists there, could survive deep within vast oceans under intense pressure. By studying how light passes through the planet's atmosphere, scientists can identify its chemical composition. This method has revealed the presence of water vapor, methane, and the combination of methane and carbon dioxide is particularly interesting because, on Earth, these gases usually don't remain together for long without some active process maintaining them. While such activity could hint at life, there are also non-biological explanations. Unusual chemical reactions under extreme conditions might produce the same signals. This is why researchers continue to study the planet carefully before drawing conclusions. K2-18B continues its silent journey around its star, holding secrets within its thick atmosphere. Whether it hosts life or not, it has already reshaped how we think about the universe. It reminds us that space is filled with possibilities, many of which we are only beginning to understand. As research continues, scientists are refining their methods to better understand worlds like K2-18B. Each new observation adds another piece to the puzzle, helping researchers separate real signals from noise or error. Space is incredibly complex, and even the most advanced instruments can sometimes produce data that is difficult to interpret. That is why repeated observations and independent verification are so important in modern astronomy. Future missions are expected to push these discoveries even further. New generations of telescopes will be more sensitive, allowing scientists to detect even smaller amounts of gases in distant atmospheres. They may also be able to study a wider range of planets, including those that are more similar to Earth. With better tools, the search for life will become more precise and more reliable. At the same time, scientists are expanding their understanding of what life could actually be. For a long time, the search focused only on Earth-like conditions, liquid water, moderate temperatures, and familiar chemical environments. But discoveries like K2-18B are challenging those assumptions. Researchers are now considering that life might exist in forms and places very different from anything we know. Extreme environments on Earth already provide clues. Life has been found in deep ocean vents, in highly acidic lakes, and even in frozen regions where conditions seem almost unlivable. These examples suggest that life can adapt in surprising ways. If that is true here, it could also be true on distant planets with entirely different atmospheres and pressures. Another important part of this search is understanding how planets form and evolve. By studying different types of worlds, scientists can learn how atmospheres develop over time and how conditions change. This helps them identify which planets are more likely to support life and which are not. Every new discovery improves these models and makes future searches more targeted. K2-18B is just one example among thousands of known exoplanets, yet it stands out because of the questions it raises. It shows that the universe is far more diverse than we once believed. Planets come in many sizes, compositions, and environments, each with its own story. Even if no life is ultimately found on K2-18B, the knowledge gained from studying it is still incredibly valuable. It pushes science forward, improves technology, and deepens our understanding of the cosmos. Each step brings us closer to answering one of humanity's oldest questions. For now, the universe remains quiet, keeping its secrets hidden across unimaginable distances. But with every new discovery, that silence feels a little less empty. The search continues, driven by curiosity and the desire to understand what lies beyond our world. The journey to understand worlds like K2-18B is not just about distant planets. It is also a journey of understanding ourselves. Every discovery in space changes how we see our own planet and our place in the universe. Earth, once thought to be the center of everything, is now known to be just one world among billions in a vast cosmic ocean. As scientists continue to explore, they are also improving the way they interpret signs of life. Not every unusual signal means biology is present. Nature can produce complex chemical patterns without any living organism.